This video, we're going to look at El Nino and La Nina, phenomenon that affects the whole globe. Even though it affects the Western, Eastern Pacific, the impact here impacts the whole world. So on the screen, you'll see on the left side, this is the normal pattern. So I'll put normal. Where you have these winds blowing eastward across, or westward, across the Pacific, blowing that warm air towards Australia, the Philippines, Papua New Guinea, Indonesia. And what that does, it allows cooler water to well up on the western coast of South America, and that drives the fishing industry. It keeps, like I talked about in that last video, that Atacama Desert very dry because that water is very cold. And then in the El Nino pattern, what you have is what you see on the right. These trade winds weaken, and that warm water tends to hang out here in the Eastern Pacific, and it kind of blocks this cold water from coming up from Antarctica and from upwelling from deep under the ocean. So right here, this is the big El Nino pattern. And this has impacts all over the world, including right here in California. So you'll see the impacts to us regionally here in California is typically we get a wetter winter. More rainfall, and then the northern plains of the United States stay warm, or are warmer than normal. The East Coast, New York, all that stuff up there is drier, and then in the South it's cooler than normal. And we'll get to the next thing. The subtropical jet stream is further south than normal. So that is our local area. This is the global impact that you really have to understand. Whenever something happens in one part of the world, those impacts ripple all the way across it. So we already mentioned where we're at in California is going to be wetter. But if it's wetter here, then it's going to be drier in other places. Remember, most of this moisture used to go across the Pacific and end up over here, but now it's not going there, it's falling in North America. It makes a lot of sense. This Western Pacific area is going to be a lot drier. Okay, Thailand, Cambodia, Vietnam, Australia, they're not going to have a strong monsoon season. Same thing with India. India is going to dry out, as well as equatorial Africa and southern Africa. And we mentioned earlier, it's going to be a little drier in the northeast U.S. and across the top part of South America. But it's also going to be wetter in other places. Like it's wetter here, it's going to be wetter in Western Europe, down here in Argentina, South America, this Eastern Africa, which, by the way, this is where humans started. The earliest evidence of humans is right there, the cradle of humanity. And then this right here is the Korean Peninsula, part of China. So just make a note on your paper that these different regions, just name the different regions and what happens to their rainfalls. Do they get wetter, drier, warmer, cooler? And let's get into more specifically this jet stream. You may have heard of this jet stream. It's going from the west coast to the east coast. That's why it's faster to fly to the east coast than fly back. It's usually go to New York, your plane ride will be about half an hour shorter when you're going towards the east than when you're coming back. So in the El Nino year, let me write that here. And remember, we're talking about El Nino year, we're talking about the winter. The word El Nino comes from Baby Jesus, basically. That's what they named it. This was first really noted down, I think, in Chile and South America, and being Spanish speaking, meaning the Christ child. This was a change that they noticed during the, not their winter, their summer, but during December 25th, December, January season. El Nino winter, and over here, the opposite of El Nino is La Nina. And that, as you guess, has basically the opposite effect. So this is the El Nino we talked about, wetter. This jet stream is very strong. This equatorial Pacific jet stream, that polar jet stream is not as impacted, and that gives us that warmer weather across North America, Canada, and more moisture, coming from the Pacific, falling on the lower part of North America. And then La Nina is when you have colder, water than usual out in the Pacific. And that brings drier weather to us in California, which can be a real problem. We've had some real dry summer, winters in the 2010s. We've been okay the last 5 or 6 years. It's 2025 now. But you can see that in La Nina, the Pacific jet stream is not as strong. This high pressure is kind of blocking that Pacific jet stream, and that polar jet stream comes down and brings some of that moisture in, makes it wetter in the northwest, up in Washington State, Oregon, but also makes it colder down in central Canada and drier across the south. So remember to make a note of El Nino and La Nina. They're separate events, all based on the temperature. El Nino, make a note of this right here. Warmer ocean temps in this part of the Pacific, which is the Eastern Pacific. Eastern Pacific. And La Nina is colder than normal here. All right. More about La Nina. Don't forget about La Nina. Here are just more graphics, a nice little diagram. Remember, we got this. This is the moisture, the wet moisture. The moisture that we got for El Nino goes further over. La Nina falls in Indonesia and Southeast Asia. And remember, if we have less water coming to us, it's not less water total for the world. It's just going in another direction. All right, so hurricanes is something that we're really focused on. They cause a lot of destruction. They're getting worse because of global warming. So during an El Nino, so it's hard to see there, so I'll write that down again. El Nino. We'll see more hurricanes in this region right off our coast. There's less wind shear. And what wind shear is, are wind currents going perpendicular to or parallel to the ground, coming like this. And when you have wind currents going like this, it's hard for the storm when it's going up to start spinning because it gets all broken up. So with less wind shear, you're just going to have more hurricanes because the spinning, the heat and the energy doesn't get disturbed. Now over in the Caribbean, you're going to get fewer hurricanes. So you can believe that the weather forecasters, insurance adjusters are paying a lot of attention to this. So fewer hurricanes because there's more wind shear, you may have guessed. And that wind shear is breaking up the hurricanes before they get started. And this whole region, you'll see here, remember the equator is about right there. You're going to get warmer and wetter too. Of course, you're going to be warmer and wetter where you see those hurricanes in that top image. And this is a fascinating diagram I wanted to show you, showing like these giant columns of water evaporating from this increased heat, increased temperature of the Pacific right here, driving these wind patterns. And you can see these arrows going down. This is dry, cool air descending. Dry, cool. Descending air. And remember that that dry, cool air, you're not going to get any rain from that. So we can see this is going to be drier wherever that dry or cool air goes. El Nino. Remember, that's when we get wet. Now, La Nina is the opposite, right? Do you see a bunch of clouds coming up by where we're at? No, you see that dry, cold air. And this is going to give us less rain. Not in total, because you notice how these clouds just shifted their location. They're still there. That moisture hasn't gone anywhere. It's just going somewhere else. So make a note. Make sure you write down, on your notes, El Nino. For California, we're gonna get wetter. Okay, La Nina, we're gonna get drier. And make sure. Let's go back. El Nino, we're going to be wetter, but the East Coast is drier. The Eastern Pacific, or the Western Pacific is going to be drier during El Nino, wetter during La Nina. The best thing to do is just kind of remember what El Nino is, us getting wetter. Then you'll remember that means the other side of the Pacific is drier, and just switch those two things for La Nina. The trends just switch. All right.